Okay, let us continue our story. Come on back. We'll keep on going and add some ductworks to this. Okay, now, we've been adding these returns, these supply and these return terminals, just in plan view. We've been putting them at 8 feet above the ground. That's kind of looking okay in terms of as we go. Just to confirm that they're actually showing up at the right level and like Elvis is working out in good 3D space, it's probably a good idea to actually shift yourself over and look at it in 3D also, so you sort of get it from both perspectives. So if you take a look at the building in 3D, let me pop on out there and I'll rotate it around the way you're probably going to look at it first. It may be a little bit hard to tell right off, what's going on because, and from this perspective, it's hard to see just what level they are. So you can rotate that around to wherever you want it to be. And we can kind of take a look at it that way. There's some other ways we might go through and do this too. For example, there's that, we could take our 3D view and use the section box to only really focus on level 2. So we're not looking at the entire building. And that's another way to approach it. Let me see if I can make that work here where I'm going to duplicate this 3D view.
These were offset by 8 inches. That means they were below.
Oh, actually, I offset them 8 feet.
8 feet.
So up above.
Oh.
So level 2 plus 8 feet. Let's see if this is going to work. Let me say level 2 only. And in level 2 only, let me see if I can pull down the little menu where I can say, can I get that to look like floor plan 1, Oh, it's interesting. It only wants to do floor plans. It doesn't want to do ceiling plans. That's kind of really strange. We'll make it work. Let me show the section box. Actually, I am showing the section box. Why don't I see my section box? Are you hidden? Hang on, that's the analytical model. Yeah, where are we going? There's my section box. It's hidden from me. I don't like that. So I can pull that up a little. Just move the model. That wasn't a very good thing to do. Just trying to get a better sense in 3D, like where those ductworks, those ducts are hanging, or this terminal are hanging out right now. Okay, so we're looking pretty good in terms of having those things located there. We're ready now to start putting some ductwork in. So let's go back over to the ceiling plan and see if we can figure this out. Okay, like what I tend to suggest with the plumbing lines and the laterals and stuff like that, I'm going to suggest sort of a similar thing in terms of how we go through and work with this ductwork, where it's probably going to make sense to actually run the main duct lines to the approximate location where you think they're going to be, as a starting point, connect things into it, and then we'll have the system optimize the sizes and try and figure out exactly what the calculations tell us where things want to be. But it's kind of good to start thinking about in this space, for example, if the air handler is going to be over here in this little mechanical room, where do I want my supply line to run? Where do I want my return line to run? And just think about, how we want to arrange them so they're not going to run into each other horizontally. Okay, so I put these guys at 8 feet. Okay, I have, what side I decided had between the different spaces here. I got 12 feet to go there, so I actually got about 4 feet to work with, less the floor, less the structural, stuff like that. I still want to keep it fairly tight in here. So I'm going to just decide as I'm running these, to kind of put maybe, what will I do? I'll put the returns below the supplies. I'm just going to sort of give them a little bit of a vertical differentiation so they can pass past each other if they need to. Okay, so coming back over here into that ceiling plan, let's start running some ductwork. Okay, you can choose different types of ducts. You know, whether you want to have rectangular ducts and whether they want to have, radius elbows or mitered elbows, whether they want to have taps or T's. The difference is really, you know, as you run these different types of systems, they have different space requirements to actually make the connections. Things that have radius elbows tend to need a little bit more room to make the radius as opposed to a mitered elbow, but they also are more efficient because the air flows around them pretty smoothly. So I'm just going to go through and say that we're going to use the radius elbows and T's, the default for right now, but as we get more fine in this, we can start just defining systems in different ways. The duct actually has some sort of notion of a default width and height. You can leave it at 12 by 12, or you can make it 12 by 16. Again, that will ultimately get sized, you know, by the system. We'll figure out exactly how big it needs to be in order to supply the air to these 3 different terminals. Okay, but I'll leave it at its default right now. It's suggesting an offset off the ground of 9 feet, and again, I'll sort of do that. I want it to be above the registers. Okay, we'll kind of connect them on in. So let's just think about running this duct. I'm going to run something to, how about on the supply side first? Every duct has some sort of system, supply or return. So what I'm going to do is, I'll run a duct, just kind of over in this neighborhood. I'm going to leave a little bit of distance between the terminal and my main duct. Going to come on down here, run some main line. See if we can figure out why that's not visible in just a second. Okay, it's there, it's just not visible right now, and we'll sort of figure out why. Okay, a couple different things going on. One is the detail level. Let me turn that up to a higher level, like medium or fine.
Did you offset it when you placed it?
I thought I offset, you never know. Let's see what's going on there. I'm offsetting off of level 1. Thank you very much. That's not very good. If I go back to 3D, you'll actually see it hanging around down there, looking ever so barren down there. Let me go ahead and I'm going to shift that up to level 2. I could delete that and rerun it. I'm just going to push it up to level 2 and say that it's 9 feet off of that. Thank you very much. I'm always finding things the hard way. Okay, there is that piece of ductwork. Again, let's take a look at it. It thinks it's a supply air duct right now. Okay, we ran it on down there. The nice thing about running ductwork is, if I go through and let's say I'm going to run it into this little closety area over here, changing that so it's level 2, 9 feet up. If I go through and join things, looks like it didn't join. Okay. It'll actually go through and depending on the type of system, it'll make that, it'll put the right elbows in there. So if you're drawing just arbitrarily, let's say I put a piece of duct down here and I continued over here and I swooped it up to here, and this is not a very efficient design, so don't go ahead and repeat this. But as I go through and do that, it'll put all the elbows in. It'll put all those bends and elbows in there to go through and run that thing. So as a starting point, I got some basic ductwork over there. I can take these all out. These are all just pieces, very much like the pipe pieces were the other day. But as we're doing this, it's actually doing a pretty good job of going through and creating a basic system. So if I look at that in 3D again, there you go. So I got my little sense of the system in there. It's waiting to attach to some sort of air handler in the closet, but I got a piece of ductwork in there. Okay, now as I go through and connect these things actually to the terminals, what do I want to do? I tend to have other pieces of duct that'll come off and run over close. You will find that I tend not to connect them directly because even with a level 9 and the 8 feet there, it may not actually connect directly with a lot of hard ducting in there. Okay, yeah, I might have to actually raise it up a little bit higher or put a different sorts of system as opposed to radius elbows. Might have to have ones that have taps on them so that it could actually just sort of attach the terminal just right to the bottom of the piece of ductwork. What I'm going to do is actually stop and use a little piece of Flexi Duct to make the final connection. Said no auto route solution was found there. Let me figure out what's going on there. System, duct, supply, 9. I get it close. Oh, I think I got it too close, and it was trying to do the final thing, the auto routing, which is, it's complaining that it can't. Let me see if I can make that happen over here. If I get it really close and say I want to connect you, it's going to say, hey, there wasn't enough space to create the required fittings. And really what's it's all about is the heights, because 9 feet and 8 feet are too close to each other. I'd have to leave more space, raise the ducts, or sort of put some different type of fitting in there. So again, what I'm going to do is just go through and put in a kind of stop and short. Notice as I put them in there, it goes through and puts some connection in there. In the scheme, it's not doing too bad. Okay. For the final inches, because I have this very tight space that I'm working with, I'm going to use something called Flexi Duct. Again, that's the stuff that kind of looks like dryer venting ducts. It's like coil that is made of foil and has a spring in it and stuff like that. Yeah, it's good for making those last kind of connections when you can't really fit a hardwired connection in there. I could go through and try and figure out what the transitions are. I could use the Flexi. Flexi has the advantage of, you know, it's kind of easy to route. It also has the advantage of just, if you're actually placing the ducts in the field, if the ducts get like, 4 or 5 inches off to the left or to the right or just a little bit out of kilter, that Flexi Duct gives you a little more just flexibility, not as efficient as the hard duct, but it gives you that little bit more flexibility. So what does that look like? Flex duct, I can run it, for example, the end of this to the end of that. And I'll put it in there. Oops, that's not looking good. Okay, it's all about snapping. Did I get it to snap? Take you out. Notice I put the transition on there already. I'll take that transition off, or I could leave that in there. Again, I'll say from the end here, I'm trying to get it right to the end there. There we go. The end here, top there, BD. I got a nice looking supply side system. Okay, that's looking pretty good. You ready to do the other side, the return side? Okay, it's going to be fairly similar. Level 2. I could decide whether I would like to run this in the space or out in the hallway. Let's see if I can actually do something. I'm going to leave some space for the air handler in there. I'm going to change this to, instead of being a supply system, I want this to be a return system. And I'll kind of start it over here. Say that it's going to have to make some sort of bend. Come over here. And route that out into the system too. Okay, so similar sort of thing. Oops. Now this one, well, actually, this isn't so bad. In this case, I've done a pretty careful job about making sure that supply and those return aren't going to bump into each other. So I could run them at the same level. Okay. If you're going to have something where things are going to cross over each other, then you really have more the issue of you want one higher than the other. You have to kind of really kind of work on negotiating about which one's going to be the top one, which one's going to be the lower one, based upon whichever you think is going to give you fewer kinks and bends and inefficiencies in the system. Okay, but I've been placing these all right at 8 feet. Cool thing is, if I did want to go through and change them, I can take, or 9 feet. If I wanted to change that and instead run that at 10 feet, I can change that. It'll bring the whole system up. Okay, so it understands that if you're just sort of running the system at 10 feet, it'll bring all the different pipe work that's up that way. Okay, for this one, I'll run some ducts here. Now, I'm suspecting this might actually join in. Nope, still not enough room. I'd have to run it even higher, but if I ran it much higher, I'd start getting into trouble with all my structure and some of the things that are running above. So I will, again, just sort of run some little stubby ducts that are coming close. Oh, come on, you. In that case, that's interesting. It's too short. Maybe I will just move this back. Oh, that's actually doing an interesting thing. I'll show you what it just did. I shifted the main pipe up to 10 feet. Okay, I'm placing these at 9 feet. So let's see if I can figure out to show you what it's doing. It's putting some little bendy transition in there. This whole duct's looking a little small in the whole scheme of things. 12 by 12, theoretically. Doesn't look like it's 12 by 12. It looks a lot flatter than that, doesn't it? That doesn't look 12 by 12 by me.
Is the section cut liquid?
Oh, very, very good. Thank you. There's all these things. Yeah, what's happening is we're up a little higher, so the section box is just truncating the top of it. There we go. There's this funny thing when you know that's not 12 by 12, but it's telling you it is, and like, what could it possibly be? Okay, so here, it's putting that funny little transition in there. Oh, even in here, let me take this out. If I'm up at 10 feet, what I was experimenting with is, let me take that little transition out there. I thought that I might even be able to just do a connect into, yeah, and just get it to do it that way. Because there's enough height difference that it could put a hardwired connection or a hard ducted connection in there. So I could do the same thing over here. If I give myself enough space.
Which is more expensive, the hard duct or the flex duct?
The Flexi Duct is definitely less expensive. It's just the hard duct's a better efficiency, better performing system, but more precision in the field. Flexi Duct, cheaper, easy to install, but over the next 30 years, someone's going to pay for it. Yeah, so that's the essential trade-off. Okay, so you got two examples here. Same thing in here. If I wanted to do that with the Flexi Duct system instead, I would just come out with a duct. Again, let me change this at 10 feet. It was smart enough when I did a connect into that it sort of made that connection across the 10 feet. Let's see what's going to go on here. Pull on out. Okay, did that. Okay, and then I'll just do a Flexi Duct between the end of this. Interesting. Supply air, no, your return air. Okay. So you create systems like that. So really at a high level, that's the gist of doing this. And connecting all these things together, it generally works out pretty much okay. If you can get things to pass through space so that you got your supplies, your returns, and your structure not fighting with each other, you're in pretty good shape. That's really where the challenge comes, is really how to get all that stuff fit in that small little space, because we haven't taken into account the structure yet. And I bet when we start thinking about the beams that are coming through and the beam systems, I may not have nearly as much space to run this as I would like to. So then I'll start thinking about the size of these ducts, whether I can flatten them out, or whether the heights are running properly. It takes some just thinking about how we're going to go through and do this. Okay. So just so you know where we're going to go together on assignment 5 is, we're going to go through and for a portion of your building, the building that you're working on for assignment 4, like one portion of a floor, not the entire building, but one portion, actually go through and try to do this coordination where we'll put in the structural elements, you'll put in some piping, you'll put in the mechanical, and try to get them all to fit together within that same amount of space. Okay, so that's why we're heading down this path. We really want to start being able to coordinate all this stuff together.
Is it still gonna be a group project?
Yes.
Okay. Are we just gonna choose one person's building out of the group?
Yes. Yeah. We're defining all that this afternoon, so we'll get that out so you can kind of like, figure out a way to make it, we want to have something so that we can work together, be tackleable in the short amount of time, but we're not going to kill each other. Like trying to get all done during and that's a challenge. So already be thinking about like someone else you want to be working with on this.
How many people is it?
We're thinking there'll probably be 3 of you working on every team. Okay, so someone will probably do the structural, someone will probably do the mechanical, and someone will be your coordinator who's actually like working in the next tool I'll show you to kind of pull it all together. Okay, so as we finish here today, I want to take you into the next step is really how we start thinking about model integration. I'll leave sprinklers out for now. Sprinklers actually work amazingly similar. You put sprinkler heads on the ceiling, you run pipes to them. And it's just one more layer of piping that's running through that you have to make sure isn't conflicting with everything else. But I'll hold that one for now. Although there is, out on Utopia, there's a nice lesson that kind of shows you just how to put the sprinkler heads in and kind of route them together. So there's a place to go there. So what I want to get you thinking about is model integration, how you pull these things together. Okay, so we've been working on this architectural model, we've been working on a structural model, we've been working on kind of a mechanical model. What we want to start thinking about is how you actually pull them all together. And as you try to pull them all together, there's a fantastic tool that I think several of you have been working with in some of the other classes called Navisworks, which is actually very, very good for doing model coordination. Okay, so if you haven't already downloaded Navisworks, now's the time to do it. Actually, not right now, but like over the next week is a good time to do it. Let me open up Navisworks, kind of show you what it looks like, and we'll think about how it actually works. So Navisworks is a tool that's really all about just coordinating models that have come out of a lot of other packages. And it's really, think of it as the universe, it's the Swiss Army knife of modeling tools. It lets you pull in almost anything, whether it was a DWG file or an IFC file, there's all these different file formats that come from all sorts of different CAD and 3D modeling packages. And it lets you pull them all together. So Navisworks unto itself doesn't look like it has a lot going on in here. There's some tools for redlining and kind of annotating different things that look like problems we're having in here. But where it all really starts is the notion of basically pulling your different model files together. Now, when you pull your model files together because you want to coordinate them, this is all of a sudden the place where everything that we said about, the importance of really making sure you have the same coordinate system, this is where it gets to be important, because if you pull things together that have different coordinate systems, they don't necessarily line up and you have to do a little transforming. You have to kind of shift it over so many units in X and shift it over so many units in Y to get them to actually align with each other. So it's better if they have the same coordinate system, but we can always fix things if they don't have it. But let's just kind of show you how you proceed. So Navisworks, big blank world right now. And what we want to do is basically bring in our files from other systems. So for example, we can append, and we go out and choose different model formats that we want to bring in there. And you'll find there's a lot of different model formats that are available. All the DWGs and the SATs and IFCs and Revit files and CATIA files and Venner files. It really can, it's sort of like the Swiss Army knife. It'll pull almost anything in. And the nice thing is, it can actually pull in the Revit files directly. It used to be we had to export things to a special file called NWC. It was a cache file as an intermediate data exchange format. Now, we just get the Revit files directly. Saves you a step. So I can bring in a Revit file. And let's go ahead and I'll bring in the architectural model as a starting point. Yes, this is Navisworks Manage. There's another version called Simulate, which is kind of a smaller version, a lighter version. This has like all the functionality. Again, here's Navisworks, and here's our basic model. And there's all these different things you can do. Navisworks is really kind of this incredible visualization tool. Let me kind of orbit it around. So we're hanging around in here. I can do all sorts of things. Oh, let me walk. Let's see if I can even under the walking. Ba, 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 ba. That's above and below. I'm trying to find the point where I turn on gravity. And let me even put the third person in there. You can put your own avatar in. Notice I'm actually that's not too good. I dropped to the ground. A little too much gravity in there.
Bad part isn't that you're on the ground, you have to rest your buildings above the ground.
So again?
Isn't the bad part not that you're on the ground, but that your buildings above the ground?
Well, actually, no. Well, some of it, there's no ground in this one. That's really yes. Okay, let me see if we can move ourselves around here. Maybe I'll turn off gravity for right now until I get into a space where I actually have some building. And even in here, let me go up and down. But I could do this just as easily on this machine as it's come crashing through. Oh, I do. You're right. I'm just not going to succeed today. Okay. Okay, let me look up a little bit, get myself reoriented. I got some nice ceiling planes in there. Okay, I'm sort of down a little bit, but let me pull my legs out of the ground. Okay, and now I can go do some walking around. Take a look at the space. I'm outside the building. Let's come back in. You find I'm a crazy driver. Let's see if I can go through here. Get out to the hallway. Nope. I'm going back towards the bathroom now. I can tell that. Let me switch around. If I turn on collision, which is probably a good idea, then it won't let me go through walls. Okay, now I'm out the atrium. But it's a good visualization tool. But the other thing that it's really good, it's good for visualizing. And we can walk around in the building and actually find an incredible number of problems just by wandering through. And you see all sorts of things like, oh, I see my ceiling over here. It doesn't really have any sort of soffit on the end. It's just not capped at the end. So, there's some little defect I might have noticed. So for something like this, I can say, I'd like to save this viewpoint. And I'll make a viewpoint over here. I'll say, no soffit at atrium walls. And what am I doing? I'm really just storing an issue. I'm storing something that later on someone can come back and, just take a look at this. Oh, in terms of review, I could even go through and kind of really highlight that. Okay, so that's what I want to call someone's attention to. That's an issue for someone to take a look at later. Okay. The other thing I can do, though, is I can start adding in other files. So I can append in, to addition to the architecture model, I can bring in the structural model. Okay, and it's hard to see that much came in there, but actually I can see some of the structural elements are showing up in here now. There's some beams here kind of popping in there. I can also start popping in the MEP model now, too. So let me go ahead and append this in. I'm going to append in, and I'll bring in the MEP model.
Is there a way for you to say how you're aligning the models? Like how Revit, you center to center or origin to origin? Do you have the same functionality in that?
Oh, if the model comes in and we need to transform a model, we can. It's we can shift around and kind of introduce the delta to the whole thing. So yeah, it's more explicit when it's here. Okay.
Does it automatically place from origin to origin?
Yes, it'll automatically try to line up the origins. Okay, but actually let me show you this because it's kind of another kind of cool point about it. Let me pop back out here. Another good way to align your models, and one thing that I love about grids is if you put grids in all your different models, the nice thing is it's really easy to spot if my A grid and your A grid don't line up, and I can even grab it by the handle and align them by grids. So it's a really, really good way to align, if everyone has a grid in their system, we can basically pull the grids together, and that way we're all referencing the same kind of relative coordinate system. Okay, so we can pull things together like this. Now, in this model, okay, you can actually control the visibility of things too. Oh, let me see if I can get the little model tree over on the side. I have the architectural model, the structural model, the MEP model. I can choose things like the entire model or elements of the model. For example, down on level 1, I can just choose all the curtain panels or all the doors or the plumbing fixtures, whatever it is. You can't see them all. I can make things visible or invisible. Let me go ahead and just do this. I'm going to just turn off. I'm going to right click on this. I'm going to say hide the architectural model. And now all I'm really looking at is the structural model and the MEP model together. So you can actually sort of see over in this space. Well, it's hard to see right there. Let me carry back over here. Here's the no soffit at the atrium walls, kind of with the architectural turned off. But I can pivot around from there. Or I can, again, under the selection tree, I can say that I want to unhide this. Or turn it back on. I really could control things on and off, and it's really kind of this nice way of being able to turn on and off different layers of reality to see different things. Okay, so for example, if I wanted to, how about I'm going to go up, because I think in this model, that's actually the plenum space right there. Looking in here, let me turn off the architectural model, hide it. See if I can look around. There's the ceiling. I'm trying to see where the ductwork is that I already have in here. Maybe it's up another level still. That's poking up. Oh, there's some ductwork. I see it now. There we go. So you see some ductwork. It's sort of hidden by the ceilings right there. How about maybe in the structural model on level 2 or level 3? Actually, I think it's probably in the architectural model. Or there. Let me hide this.
So the fact that the ducts are going through those beams would obviously be like a really big issue, right?
Yes. We got some problems. You can see them right there. So the way I've planned my system right now, yeah, I either got to talk to the structural engineer about kind of moving something, and I got to talk to the MEP person about moving something. But yeah, clearly I got some problems right there. And that's really what this is all about, is really bringing things together from the disciplines. You know, we all do our best work independently of each other, but then it all has to come on back together. And this is where we actually sort of find where those problems are. And let me just kind of preview that tool. We'll continue with how you actually can do this in a very systematic way. But that's really where we're going to be going next time. So the idea is you got it all together. I seem to have a problem. Okay, if just walking through the building you find all your problems, super, but there's actually a more systematic way of doing that. There's something within Navisworks called the Clash Detective, and it works like this. I can add some tests. I'm going to call this like ducts versus beams. And I can, for example, say that I want to go through and at a specific level, let me just find the ducts and the ducts fittings. I'll choose this as one thing I want to take a look at. And then on the other side, I'm going to compare those to the level 3. And let me see if I'll find the structural framing and the structural columns. Okay, I tend not to clash entire buildings. There might be thousands of things that'll clash. So clash sort of subsets of things you want to know about and kind of handle at any specific time. But you can say that you want to run a test. Looks like in that case it didn't find anything, and it'll have something to do with the way I selected those things. Probably on the different levels. Well, we'll just go all of level 3. There is definitely some confusion. Oh, I'll just do this. I'll just do the structural versus the mechanical now, which I'm not going to advocate you do in the longer run, but it'll get us started for now. Okay, let me try running a check of the test of those. Okay, and you'll see that basically it found, in this current version, 87 things that it thinks are sort of problems. Now, a lot of these problems may be things like, oh, you have a beam running into a ceiling or something like that, and that's okay. You know, we're going to learn to sort of classify some things as being okay clashes because we don't always model things incredibly carefully and put punch outs and things. But the way this basically works is we can choose any clash. For example, let me see if I can shrink this up a little bit over here. And as you choose a clash in the list over here, it'll highlight for you and show you where that clash is. And this is some piece of structural strut, some sort of brace is coming out. It looks like it's hitting the ceiling plane. Those don't look so interesting. Let's come on down and start to see if we can find something more interesting. That looks kind of interesting. Let's see what this is. This is a case where some wide flange is actually hitting some radius, some elbow or T or some piece of the mechanical system. So this is a case where we probably would want to go through and say that, something's got to change. So when we come back together on Thursday, we're going to talk a lot more about this tool and how we can run different tests, kind of clashing and comparing different things, and use this big list that gets created to actually create a little hit list of things that are problems that we need to solve. Okay, so that is Thursday. Come on back for more fun.